Good morning, good afternoon, and good evening. This is Varicella Academy presenting prions. You know, prions, those bizarre hell proteins that are able to turn other proteins into them, and then are responsible for diseases like scrapie, where sheep literally scrape their wool off them compulsively. Or mad cow disease. Originally, prion diseases were responsible for around 100 deaths a year in the 1970s, but as of 2022, 500 people a year died to prion diseases every year. The three main causes of prion conditions in humans are the consumption of infected brain and spinal cord tissue of creatures that do have prion diseases, like in the case of mad cow. There's also genetic components as well, like in the case of that disease that makes it so people can't sleep forever and then they just end up dying from lack of sleep. But unfortunately, the third cause and the scariest is it's sporadic. A lot of the time we just don't really know why. But thankfully it's rare, right? It's like winning the world's crappiest lottery. Congratulations, you came up snake eyes. Have fun with your brain. So yeah, just to round out this little bit about prion diseases in humans, they are very rare, thankfully. However, symptoms progress rapidly, requiring help with daily needs, going to the bathroom, feeding, and just all of the help, hospice care, palliative, expensive. It's expensive and very sad. And always fatal. So keep that in mind. So now that we've established the abject horror of prions, let's talk a little bit about how they're made, what they are, how they work, and maybe, just maybe, there could be some positives to this. So a bit about proteins and their complexity. So you got four main levels: primary, secondary, tertiary, and quaternary. And the idea here is that at the very base level, it's just a chain of amino acids. It's a polypeptide chain. However, because of the way the amino acids interact, they're able to have their attractions to each other. The amino acids will attract towards each other and form sheets and alpha helices. And these sheets are able to aggregate to each other again and make a 3D structure of these alpha helices and beta sheets. And then these agglomerations can interact with other agglomerations in the 3D. So you end up having an increasingly complicated agglomeration that is still organized agglomeration of the tertiary level 3D amino acid structures all put together in order to make your cellular machinery. So I'm sure we all remember this from bio class. It's the central dogma of molecular biology, the process of going from DNA all the way to mRNA, tRNA, and eventually into our proteins. In eukaryotes, this is more complicated than it is in prokaryotes, and maybe archaea have their own thing. I'm not that well versed in archaea. But the idea here is that we have our information in DNA, and based off of what kinds of modifications are made to that DNA, and then modifications to the mRNA, and then modifications to the tRNA, we can end up getting a different protein at the end that then ends up serving its purpose and however it ends up affecting the body. But in the case of prions, it is yet another modification of the protein itself, and it being able to have a different conformation that, in the case of humans, is disastrous and will kill us slowly and brutally. But in the case of other organisms, our most closely related other kingdom, fungi, it can actually be a very functional, helpful part of their immune system and serve as an epigenetic way to deliver even more information between organisms or within the organism itself by being able to have the protein change conformations and be able to affect the proteins around it. And the fungi use it as part of their immune system. Now, as to the actual structural mechanism of how this works and what triggers a prion to go from one conformation to another, we have a long way to go until we truly understand how this works, and we can go ahead and scratch out that sporadic cause for prion diseases, and hopefully harness the power of prions in fungi maybe being able to use it as some form of medication or other relevant biotechnology. But it does seem to be that, at least based off of this article from 2019, that it does have something to do with electrostatic interactions and how pH affects it. So in one experiment, they just ended up doing titration on the actual prions in solution and being able to see at what point they would change conformation. And apparently, as it gets more acidic, you end up having your H187 histidines being able to cause this change due to protonation. Okay, look, I'm getting a bit too far into the weeds. This is supposed to be entertaining. A part of me does have a little bit of a headcanon that these boys probably make use of prions as well, given that they are basically just sentient fungi. I'm Varicella, and I'm barbecuing in your yard.